Hello guys, welcome on Tesla Adventures. In this video today, we are continuing further the magnetism, and obviously we know that we are studying the moving charges in magnetic fields. So today let us discuss a very important and very rare concept of magnetism, which I think you are not taught in your respective coachings. So this is a very important and rare concept of magnetism. Just imagine that there is a current carrying wire which is carrying a current I in the upward direction, and there is a charge which is moving with the velocity of drift velocity. So the drift velocity is the velocity with which the electrons are also moving inside this wire in the downward direction. So if you will see that the magnetic field created by this wire on this charge will be in the downward direction, which means inside the plane of this screen, and the force acting on this positive charge would be towards right hand side, magnetic force. So from the ground it can be clearly observed that this charge would be moving away from this wire. But let us imagine that there is a observer which is also moving with the same drift velocity as that of this charge in the same direction. So this observer is continuously watching this Q, and from the ground frame it could be observed that Q would be approaching towards this observer. But if if we are in the frame of this observer, so this is observer frame, then you can see that this Q would be at rest. And obviously there are two questions which are arising in this situation, that whether this current would be seen by the observer in the wire or not, and the second question is the fact that how would this observer justify the motion of Q towards himself, which means that obviously if we are in the observer frame, then this observer would be observing this Q to be moving towards him, like that. And how that observer will justify the motion of Q towards this side, towards him. And this is the observer, obviously it is at rest. This is observer. So there are two questions. First question is the fact that whether he would see the current in the wire or not. This question is arising due to the fact that if this observer is also moving with the velocity that is equal to the velocity of electrons in this wire, then we can say that the electrons are relatively rest with respect to this observer. And if the electrons are relatively rest, then how would the current will flow? So let us analyze the situation in detail. Let us see that first of all we know that there would be the current carrying wire is electrically neutral, and due to the fact that it is electrically neutral, equal number of positive and negative charges would be situated in this wire. This blue color charges are positive and this red color charges are negative. Now this negative charges are electrons, and these are at rest with respect to this observer because they are moving in the same direction with the same velocity. But initially in the ground frame this positive charge was at rest, but as observer is moving in the downward direction with the drift velocity, therefore this positive charge would also be moving in the upward direction with the same drift velocity, and hence there would be a current which would be observed in the wire in the same direction. So this is the justification for the current flowing in the wire. And the second thing that we know, that in the ground frame the wire was electrically neutral, which means that in this fixed length of the wire there are equal number of positive and negative charge. And if we assume these charges to be separated by a certain distance d, then in the ground frame the distance between both positive charges was also equal to the distance between both negative charges, which means that the charge density of positive charge and charge density of negative charge in ground frame was equal. and therefore the net charge, this current carrying wire was electrically neutral in the ground frame. But as we know that as observer is moving with some velocity, therefore electrons would be at rest with respect to this observer, and this positive charge would be moving in the upward direction with respect to the observer. And we know that theory of relativity explains two very interesting concepts of time dilation and length contraction. So we would not be getting in deep in that theory. We would be making the separate videos for theory of relativity, general and special. But in this video we are not going to dig in more deeper in that theory. We are just using the reference of that theory. We know that if some object is moving with a speed that is quite large, then obviously that the time of that object seems to be dilated, and the length of that object seems to be contracted with respect to the ground observer. So the length, the separation between these two positive charges d dash would be now less than d due to length contraction. And you can see that in this fixed length of the wire, more would be the positive charge and less would be the negative charge, which means that this wire would be now positively charged, and this positively charged wire will now repel this Q by the electric force. So observer will see and observer will justify the motion of Q towards himself. So this is very important to note that in the ground frame, this Q was moving towards the observer due to magnetic force, and in this frame, in the observer frame, this Q is moving towards the observer due to electric force. So this is very important that these forces, electric and magnetic forces, are frame dependent and they are interconvertible. So the electric force in one frame becomes magnetic in force in other frame, and magnetic force in one frame becomes electric force in other frame. So this was the very important concept, and now I'll in the other video, in the next video, I'll be explaining such another concept of magnetism which is very rarely found. Thank you.